So this was a little more tricky than I thought. I was originally going to use a switch, but my switch is going to be touching the battery to those conductors for simplicity. So the current will flow through this black wire into the magnet that I talked about earlier. It's magnet wire wrapped around a nail to provide the magnetic field to attract this armature. I had to change my scheme a little bit. So the current will go through here, energize the magnet, continue to this green wire. I took some finagling here too because there was a lot of resistance in these chrome plated nails, so I had to jimmy with those for quite some time. The current will continue through the armature to this other screw, and every time the magnet is energized, it'll open the switch, which will de-energize the circuit momentarily, and then when the magnet releases again, the switch will close, re-energizing the circuit, and the cycle will repeat. So you'll see the armature flicking back and forth, and you might even catch the spark. I had to move that wire down there. I had to get copper contact there so it would work. So let me do this, and you watch. I don't know if you can hear it or see the spark. So let's turn on our radio from 1970. So that's the first step. So now I have a working relay, spark gap generator, transmitting electromagnetic fields to my AM radio, so that if I'm on a toilet stall when the shit hits the fan and I need to communicate with somebody 3 feet away, I can do so via Morse code. The next step is to take this microwave transformer and put it in series so that the primary is getting a fluctuating DC pulse input, and I'll see what the output does. Based on the fact that I could barely get this working due to the resistance in the circuit, I don't think there's going to be enough voltage to power that transformer coil, but we'll see. So I'll do that.